So here's an example. We have the moon, and we want to raise an object that's 250 kilograms of mass from its surface to some stationary position above the moon. So we're given our two distances, or it's basically increasing from going from point A to point B. Again, potential energy in itself doesn't really mean much, but we're always interested in what is the change in energy, because if we want to go from point A to B, that difference in energy will tell us how much energy is required to get from point A to point B. So what we're looking for is, what is the work? So work is equal to the change in energy, so change in potential energy. So change in PE. So in other words, we're trying to find out what is the potential energy above the surface, and we're going to subtract from that the energy at the surface. So we're going from the surface to that point above. So just plug in our equations. We know that energy, so potential energy for a object in space, is given by the equation that we derived last in the previous lesson, or previous video, negative g mm over r. So no square in this one. It's just g mm divided by the distance. So we end up with the following expression: negative g mass of the multiplication of the mass of the two objects divided by r2 minus negative g mm over r1. Now, before we go ahead and plug things in, if we do a little bit of algebra and simplify this expression, it makes our life a bit easier. So I'm going to factor out the negative, the g, the m, and the little m. So I have minus g m m. And what's left over is I have 1 over r2 minus 1 over r1. Now just go ahead and plug in our values. We have negative 6.67 times 10 to the negative 11 newtons meters squared per kilogram squared. And we're going to multiply by the mass of our two objects, 7.35 times 10 to the 22 kilograms. Our other object's 250 kilograms. And we're just going to multiply by the difference of the reciprocals of those r values. So it's 1 over 1.74 times 10 to the 7 meters minus 1 over 1.74 times 10 to the 6 meters. Plug in, well, this actually comes out to be a negative value. So the negative and the negatives cancel. We end up with a positive value for energy of 6.3 times 10 to the 8 joules. Which makes sense. We need to use energy to get away from the surface of the Earth.